Okay, so we have a conical tank that is pointed downwards, and we have a radius of 4 and a height of 15. And you can look at this diagram through the red arrow. Now, we know that the volume of a cone is V equals 1/3 pi r squared h. Now, they gave us that water is flowing into this tank at 12 centimeters cubed per minute. And the reason it's positive is because it's filling up this cone and it's not exiting. So the volume is increasing. Think of the empty space as the empty space is getting taken up as water continually fills it. Now, we know that dV over dt is going to be a constant because we cannot control how much water is going into this thing. It is always just going to be continuously flowed at the same rate, and we know it's positive. Now, dh over dt. If you think about it, the same amount of water as the radius increases, the same amount of water will take up less height, which means dh over dt is positive, but it's decreasing, which basically means that eventually dh over dt will approach 0, but not in this problem. Okay, so the problem is asking for the instantaneous rate of change of the height at a certain height, and in this case the height is 6. Okay, but the problem is this volume equation has r squared and h, and if we take the derivative we're going to have some nasty numbers because this will involve the product rule, and the product rule will also be accompanied by dr over dt and dh over dt. Well, we don't know what dr over dt is, and we don't know what dh over dt. That's two variables for one function, so we can't do that. Basically what I'm saying is we have to get rid of r. So how do we do that? Simply use a ratio. This 4 to 15, this 4 is the radius and 15 is height. If you have the same angles and it's a right triangle, well then you're good to go because these ratios are always maintained. That's why if you look at the green section it says 4 is to 15 as r is to h. Doing some math, you can say that r is 4 over 15h. Plug that back into the equation and you're going to have v equals 1/3 pi 4 over 15 h squared times h. If you solve all the math, you're going to get v equals 1/3 pi 16 h cubed over 225. Now that's a problem we can do. Take the derivative and you're going to have pi 16 over 225 h squared dh over dt. You know what dv over dt is, and you know h is 6. So if you plug in all the numbers and then divide to get dh over dt, you're going to get your answer. The most important thing to learn in this part is that you have to get rid of the r, and to do that you have to set up a ratio. And this is going to be true with most related rates problems for conical tanks. And remember, dv over dt is positive because water is flowing in. Thank you.